Fragile bodies and delicate machines must withstand extreme conditions, from intense radiation to the crushing forces of launch and the complete absence of atmosphere. Every rocket launch is a feat of engineering precision and human bravery. Astronauts undergo years of rigorous training to prepare for the physical and psychological demands of spaceflight. They learn to respond calmly in emergencies, to live in confined quarters, and to perform delicate scientific experiments far from home. The risks are real, but the rewards are even greater. The chance to expand our knowledge, to push the boundaries of what humanity can achieve, and to inspire generations to look up and dream. Leaving Earth is more than a scientific mission. It is a profound human moment, a testament to our innate desire to explore, to understand, and to connect with the universe. As we cross this galactic gateway, we carry with us the hopes and dreams of all who have looked up at the stars and imagined a future beyond the sky. The rocket is not just a machine, it is a symbol of human potential, creativity, and courage. Each journey beyond our atmosphere adds a new chapter to our story, revealing not only the wonders of the cosmos, but the boundless spirit of discovery that defines us. The first step through this gateway is the boldest and most transformative. It reminds us that no matter how vast the universe may be, we are explorers at heart. With every mile traveled beyond Earth, we move closer to uncovering new worlds, new knowledge, and perhaps answers to the greatest mysteries of existence itself. The galaxy is calling, and humanity has finally begun to answer. Before we venture far into the vast Milky Way, it's only natural to pause and explore the wonders of our immediate cosmic neighborhood, the solar system. Think of it as the front yard of the galaxy, a place where familiar and strange worlds coexist, each with its own history and secrets waiting to be uncovered. The solar system is a marvel of cosmic architecture, a delicate but dynamic stage where gravity is the unseen choreographer, guiding planets, moons, asteroids, and comets in a complex dance around the sun, our brilliant and life-giving star. At the very heart of this neighborhood shines the sun, a blazing sphere of hot plasma whose gravity holds everything together. It's easy to forget just how critical the sun is, not just as a light source, but as the anchor for every orbiting body. Its immense energy drives the climate and weather on Earth and sculpts the environment on every other planet and moon. Around it, the planets circle in elliptical orbits, each following a path forged billions of years ago during the chaotic birth of the solar system. Our first stop is Mercury, the smallest and innermost planet, a world of extremes. Mercury is a scorched and barren place where temperatures soar to nearly 800 degrees Fahrenheit, 427 degrees Celsius in the daytime, and plunge to bone-chilling lows at night. Imagine standing on its cratered surface. The sun would appear nearly 3 times larger than it does from Earth, scorching everything in sight. Despite its harshness, Mercury tells us an important story about planetary formation and survival in the furnace close to a star. Its surface is scarred by countless impacts, each crater a testament to violent collisions in the early solar system. Studying Mercury helps scientists understand how planets can hold on to or lose their atmospheres and how proximity to a star influences their evolution. Moving outward, we reach Venus, Earth's enigmatic twin, often called the morning star or evening star because of its brightness in our skies. But beneath that dazzling appearance lies a hellish world cloaked in thick, toxic clouds of sulfuric acid. Surface temperatures on Venus hover around 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. The crushing atmospheric pressure is over 90 times that of Earth's. This extreme greenhouse effect makes Venus a natural laboratory for understanding climate change, atmospheric dynamics, and planetary habitability. Venus reminds us how delicate the balance is that keeps Earth hospitable, and how small shifts in atmosphere can transform a world utterly. Then there's Earth, our precious oasis of life. Positioned just the right distance from the sun, with a protective magnetic field and an atmosphere rich in oxygen and nitrogen, Earth is uniquely suited for life as we know it. Its abundant water, diverse climates, and dynamic geology make it a treasure chest of biodiversity and complexity. Our planet is the benchmark for understanding what makes a world habitable, and serves as a reference point for exploring exoplanets beyond our solar system. Beyond Earth lies Mars, the red planet, a place of dusty deserts, towering volcanoes, and deep canyons. Mars captivates scientists and dreamers alike with its tantalizing hints of past water and the possibility that it once harbored life. The planet's rust-red hue is caused by iron oxide, or rust, coating its surface rocks. Mars also has the tallest volcano in the solar system, Olympus Mons, which stands nearly 3 times the height of Mount Everest. Recent missions have uncovered ancient riverbeds and signs of seasonal methane, sparking hopes that microbial life might still lurk beneath its surface, or that humans might someday call it home. Mars is both a window into our planetary past and a potential future for humanity's expansion into space. As we travel farther out, the gas giants come into view. Jupiter and Saturn, enormous worlds made mostly of hydrogen and helium, with swirling storms and powerful magnetic fields. Jupiter, the largest planet, is a colossal gas giant with a colorful atmosphere marked by the Great Red Spot, a gigantic storm that has raged for centuries. Its dozens of moons, including the icy Europa with its hidden ocean, are worlds of immense interest for astrobiologists searching for life beyond Earth. Saturn is famous for its breathtaking rings, composed of countless icy particles that glitter in the sunlight. These rings are a delicate and complex structure, constantly shaped and reshaped by Saturn's moons and gravitational forces. Saturn itself, like Jupiter, is a gas giant with swirling storms and a magnetic field that dwarfs Earth's. Together, these giants teach us about planetary atmospheres, magnetospheres, and the early history of the solar system. Further still are Uranus and Neptune, the ice giants, mysterious worlds cloaked in deep blue hues caused by methane in their atmospheres. Uranus rotates on its side, making its seasons wildly different from any other planet, while Neptune, the farthest planet from the Sun, boasts supersonic winds and the fastest storm in the solar system. These distant giants challenge our understanding of planetary formation and dynamics, hinting at diverse evolutionary paths planets can take under different conditions. But the solar system isn't just about planets. It is teeming with smaller objects, moons, asteroids, and comets, each adding layers of intrigue and clues to the story of our cosmic origins. The asteroid belt between Mars and Jupiter is a relic of the early solar system, a collection of rocky fragments that never formed into a planet, offering insights into primordial materials. The icy comets that swoop in from the outer reaches bring ancient compounds, including water and organic molecules, which might have played a role in seeding life on Earth. Each of these celestial bodies is a chapter in the grand story of our solar system, a complex and dynamic neighborhood shaped by gravity's invisible hand. By understanding these worlds, their histories, and their interactions, we gain perspective on our place within the Milky Way Galaxy. Our solar system is a microcosm of cosmic processes at work, a stepping stone for humanity's deeper exploration into the vast expanse of stars, nebulae, and galaxies beyond. It is a reminder that before we reach for the stars, we must first appreciate the marvels of space right in our own backyard, the Kuiper Belt and beyond, stepping outside the sun's reach. As we journey beyond the familiar orbits of the 8 major planets, past the swirling blue hues of Neptune, we step into a realm that feels almost like the outer edge of our cosmic neighborhood, the Kuiper Belt. This vast, icy frontier stretches far beyond what we once imagined as the solar system's limits. It is a frozen wilderness of small worlds, a cold and distant place where the sun's warmth fades into the faintest glow, barely enough to light the surface of these remote objects. Traveling here is like crossing an invisible boundary, moving from the well-charted paths of the inner planets into a shadowy territory that's still shrouded in mystery and wonder. The Kuiper Belt is a sprawling ring of countless icy bodies, remnants of the primordial material that once swirled around the young sun more than 4 billion years ago. These frozen relics are like time capsules, preserving the early history of our solar system in their frozen surfaces. Unlike the rocky inner planets or the gas giants, these icy objects have remained largely unchanged, guarding secrets about the building blocks that came together to form the worlds we know today. This makes the Kuiper Belt a treasure trove for scientists eager to piece together the story of planetary formation and the evolution of our celestial neighborhood. Among these distant denizens is Pluto, once considered the 9th planet, now classified as a dwarf planet, but no less fascinating. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a world more complex and varied than anyone had anticipated: towering ice mountains, vast plains of frozen nitrogen, and a thin, hazy atmosphere that flickers with seasonal changes. Pluto's discovery and exploration challenged our understanding of what a planet is and opened the door to recognizing many other similar bodies lurking in the Kuiper Belt, each with its own unique story. But Pluto is just one part of this icy collection. The Kuiper Belt contains many other dwarf planets like Haumea and Makemake, as well as countless smaller objects, frozen comets, rocky ice hybrids, and mysterious dark bodies that absorb much of the sunlight that reaches them. These objects travel in orbits that are often tilted, elongated, or strangely shaped, influenced by Neptune's gravity and possibly by other unseen forces. Studying their motions and compositions helps astronomers understand the dynamic and sometimes chaotic environment at the edge of the solar system. Beyond the Kuiper Belt lies even more enigmatic territory: the scattered disk and the hypothetical Oort cloud, a vast shell of icy bodies that may extend almost halfway to the nearest stars. These regions are the birthplace of long-period comets that sometimes journey inward, spectacularly lighting up our skies. The Oort cloud remains purely theoretical, unseen by any spacecraft or telescope, but its existence is inferred from the orbits of these distant visitors. It represents the boundary between our solar system and interstellar space, a final frontier that humanity has only just begun to imagine exploring. Stepping outside the sun's direct reach means venturing into the unknown, where the rules of planetary science are still being rewritten, and the quiet dark of space holds endless questions. What else lies beyond this frozen belt of ancient ice? Could there be undiscovered worlds lurking in the shadows, or even rogue planets wandering between the stars? The Kuiper Belt is a reminder that the solar system is far more than just the planets we grew up learning about. It is a vast and varied realm, full of surprises, waiting patiently for explorers brave enough to journey to its farthest edges. In understanding this outer frontier, we begin to see how the solar system is a living, breathing system with a history that stretches back billions of years and a future that still holds is like stepping beyond the edge of a well-lit city into a wilderness of infinite night, where the cosmos reveals its deeper, quieter rhythms. Interstellar space might seem empty at first glance, a vast void stretching endlessly in every direction, but it is anything but a simple emptiness. Here, an incredibly thin soup of gas and dust drifts slowly through the void. Though spread so sparsely that a single cubic centimeter might contain just a few atoms, this matter is the raw material from which new stars and planets eventually form. Within this diffuse medium, immense clouds of hydrogen gas, known as molecular clouds, quietly gather and contract under their own gravity, sometimes collapsing over millions of years to ignite new stars and birth new solar systems. In this way, interstellar space is not a static void, but a dynamic, ever-changing environment, a cradle for cosmic creation amid the vast darkness. Invisible magnetic fields thread through this region like unseen threads weaving the fabric of the galaxy. They shape the movement of charged particles and guide cosmic rays, high-energy particles hurtling through space at nearly the speed of light. These fields and particles interact in complex ways, creating shock waves that ripple through interstellar clouds, often sparked by the violent deaths of massive stars in spectacular supernova explosions. These shock waves compress gas clouds and seed the conditions for star formation, turning death into new life in a cosmic cycle that spans millions and billions of years. As we travel further, the light from our sun dims until it is no more than a faint point among the countless other stars twinkling in the darkness. Out here, the sun is just one ordinary star, part of a vast galactic community, numbering in the hundreds of billions. This perspective humbles us, a reminder of both how vast the universe truly is and how precious our tiny home star is to the life it nurtures. The journey through interstellar space is a voyage beyond the local neighborhood, connecting us to the larger, majestic structure of the Milky Way Galaxy. The Milky Way itself is a grand spiral of stars, gas, and dust, stretching over 100,000 light-years across. It is a cosmic city bustling with stellar neighborhoods, clusters, and nebulae. Traveling through interstellar space means we are no longer confined to the sun's backyard, but are becoming cosmic travelers roaming the wider galaxy. Each cloud we pass, each particle of gas, and every flicker of magnetic energy is part of a vast interconnected system, weaving the story of how stars and planets are born, live, and die. This dark expanse also holds countless mysteries. What secrets lie hidden in these clouds of gas? Could there be places where conditions are right for life to begin anew? And how does interstellar space shape the environment in which our solar system exists? These are questions that astronomers and space explorers are only beginning to answer, fueled by powerful telescopes and robotic spacecraft that journey ever farther from home. Stepping into interstellar space marks a profound shift in our cosmic voyage. It is no longer the story of our sun and its planets, but a broader tale of the galaxy itself, a story of cosmic cycles, endless change, and the birth and death of stars. It is a humbling reminder that we are part of something far greater, an intricate cosmic web that stretches across the universe. Our journey through this vast dark sea is just beginning, as we seek to understand our place in the grand design of the Milky Way and beyond. Welcome to the Milky Way, understanding our galactic home. As we venture deeper beyond our solar system, we finally arrive within the magnificent realm of the Milky Way, our galactic home. It's hard to truly grasp the vastness of this cosmic city until you pause and step back to take in the full picture. The Milky Way is a sprawling spiral galaxy, a colossal collection of stars, gas, dust, and dark matter, all swirling together in a graceful cosmic dance. Stretching over 100,000 light-years from edge to edge, it is so immense that light itself, traveling at nearly 300,000 kilometers per second, takes 100,000 years just to cross it from one side to the other. This immense scale is difficult to imagine, especially when we consider that Earth is just a tiny speck nestled on one of its countless spiral arms. Within this vast galaxy, hundreds of billions of stars blaze brilliantly, each with its own stories, worlds, and mysteries. Our sun is but one of these countless stars, located in a quieter suburban neighborhood known as the Orion Arm, far from the bustling galactic core. Around these stars orbit planets, some familiar and rocky like Earth, others massive gas giants and countless moons. And yet, the Milky Way is much more than just stars and planets. It is a complex ecosystem that includes vast clouds of glowing gas and dust called nebulae, stellar nurseries, where new stars are born from collapsing clouds of matter, as well as remnants of exploded stars, scattered across the galaxy. One of the greatest mysteries of the Milky Way is something invisible yet profoundly influential: dark matter. Although we cannot see or directly detect dark matter, astronomers have found compelling evidence that it makes up a significant portion of the galaxy's mass. This invisible substance holds the galaxy together, providing the gravitational glue that keeps stars from flying apart as they whirl around the galactic center. Without dark matter, the Milky Way as we know it simply wouldn't exist. This unseen presence adds an intriguing layer of mystery to our understanding of the cosmos, reminding us that much of the universe is still hidden beyond our current knowledge. The center of the Milky Way is a bustling, energetic place unlike anywhere else in the galaxy. It houses a supermassive black hole Sagittarius A*, a cosmic heavyweight millions of times more massive than our sun. This black hole shapes the orbits of stars nearby and powers energetic phenomena that send out waves of X-rays and other radiation. Despite its tremendous pull, the galactic core remains a dynamic environment where stars are born and die in cycles that shape the evolution of the entire galaxy. As we journey through the Milky Way, we begin to understand it not just as a collection of stars, but as a vibrant, ever-changing city, with neighborhoods, highways of gas and dust, and mysterious forces at play. This is a place where cosmic events unfold on scales both enormous and tiny, where ancient stars quietly burn alongside newly formed ones, and where the secrets of the universe continue to be uncovered. For humanity, the Milky Way is both our cosmic address and a frontier filled with wonder. inviting us to explore and learn more about the galaxy that has nurtured life on our small blue planet. Despite all our technological advances and discoveries, the Milky Way remains largely uncharted territory. Telescopes on Earth and in space continuously reveal new surprises, from bizarre exoplanets with strange atmospheres to colossal clouds of star-forming gas and mysterious bursts of energy that challenge our understanding of physics. Every journey deeper into this galactic city uncovers more pieces of a cosmic puzzle that stretches back billions of years. The Milky Way is a place of immense beauty, complexity, and mystery, reminding us how much there is yet to explore and how intimately connected we are to the vast universe beyond our skies. Riding the Orion Arm, our spiral suburb in the galaxy. As we settle into our place within the Milky Way, we find ourselves riding along one of its many spiral arms, specifically the Orion Arm, sometimes called the Orion Spur. This is our cosmic suburb, a relatively calm and peaceful neighborhood nestled between two larger, bustling arms of the galaxy. Unlike the dense and chaotic core that lies toward the center of the Milky Way, the Orion Arm is a quieter stretch of space, making it an ideal environment for the delicate processes that lead to the emergence of life. It's the cosmic equivalent of a tranquil suburb, away from the hustle and turmoil of the galaxy's downtown. The Orion Arm is far from empty. It's sprinkled with countless stars, young and old, big and small, each telling a unique story of birth, life, and death. Here we encounter spectacular stellar nurseries, vast clouds of gas and dust, where new stars are being born even now. These glowing nebulae light up the darkness with vibrant colors, their intricate shapes sculpted by intense radiation and powerful stellar winds from newborn stars. As we glide through this region, we can almost feel the pulse of creation, where the ingredients for solar systems like ours come together in a delicate cosmic recipe. Interspersed among these nurseries are the remnants of ancient stellar explosions, the aftermath of stars that lived fast and died young in brilliant supernova. These violent deaths seed the surrounding space with heavier elements, carbon, oxygen, iron, the very building blocks of planets and life itself. Each explosion enriches the environment, reshaping the interstellar landscape and triggering new waves of star formation. It's a dynamic, ever-changing neighborhood where the past and future of stars collide and intertwine. Our solar system is just one of countless star systems nestled in this arm, drifting along at an astonishing speed of hundreds of kilometers per second, orbiting the galactic center in a slow, steady journey that takes about 230 million years to complete one full circle. This grand orbit is a cosmic voyage in itself. As we ride the Orion Arm, we pass through regions of varying star density, cosmic dust lanes, and energetic phenomena that continuously influence our local environment. The significance of the Orion Arm goes beyond just its physical characteristics. It represents the cosmic neighborhood where life as we know it was able to emerge and flourish. Being far enough from the galactic core means fewer catastrophic events like intense radiation bursts or frequent supernova that could disrupt planetary systems. This relative safety provided a stable environment over billions of years, allowing complex chemistry to unfold on Earth and perhaps elsewhere. Exploring the Orion Arm also helps us trace our own cosmic origins. By studying the stars and nebulae in this region, astronomers can piece together the history of our solar system's formation and gain clues about the conditions that made life possible. Each star cluster, each glowing cloud, is like a chapter in the story of our galactic neighborhood, revealing the processes that shaped not only our world, but countless others. So as we ride along this spiral arm, we are not just passive observers, but participants in an ongoing cosmic saga, a journey through a dynamic and beautiful neighborhood that has nurtured the life we cherish. The Orion Arm is more than just a place. It's the backdrop to our existence, a cosmic suburb filled with wonders and mysteries that continue to inspire our exploration of the universe. A visit to Alpha Centauri, our closest stellar neighbor. Leaving behind the familiar surroundings of our solar system, our cosmic journey now takes us to a star system that has fascinated astronomers and dreamers alike for centuries, Alpha Centauri. Sitting just over 4 light-years away, it holds the title of our closest stellar neighbor, a neighboring family of stars that offers an intriguing glimpse into what lies beyond our own sun's comforting glow. Though the vast distances of space make traveling there a monumental challenge with today's technology, Alpha Centauri invites us to imagine what interstellar travel might one day look like and what wonders await in star systems beyond our own. Alpha Centauri is not just a single star, but a trio, a small stellar neighborhood comprising 3 stars bound together by gravity. The 2 primary stars, Alpha Centauri A and Alpha Centauri B, are both similar to our Sun, shining with steady light as they orbit each other in a cosmic dance. Then there's Proxima Centauri, a smaller and much dimmer red dwarf star, which, despite its faintness, holds a particular fascination. Proxima Centauri is actually the closest star to Earth outside of the Sun and is home to at least one confirmed exoplanet, Proxima b, located in its habitable zone, where conditions might be just right for liquid water and potentially life to exist. This trinary system illustrates the diversity and complexity of star systems in our galaxy. Unlike our solitary sun, many stars live in shaping each other's lives in profound ways. In some cases, these pairs can be so close that their outer atmospheres actually touch or transfer material from one star to the other, leading to spectacular outbursts of energy or the formation of exotic objects like neutron stars or black holes. These interactions produce unique radiation patterns that astronomers can detect across vast distances, revealing the hidden dramas playing out in star systems far beyond our own. Then there are the red giants, the majestic elders of the stellar family. These stars have entered a late stage of their life cycles, having exhausted the hydrogen fuel at their cores that once powered their steady glow. In response, they swell enormously, ballooning to sizes hundreds of times larger than their original form. A red giant's surface cools as it expands, giving the star its characteristic reddish hue, a gentle but dramatic transformation visible across the galaxy. During this phase, these stars begin to shed their outer layers in powerful stellar winds, releasing vast amounts of gas and dust into the surrounding space. This material doesn't simply disappear, it enriches the galaxy, providing the raw ingredients for new stars, planets, and potentially the seeds of life. Exploring these stars helps us piece together the grand cycle of stellar birth, life, and death that fuels the galaxy's continuous renewal. Binary stars illustrate the complexity of gravitational relationships in space, showing how stars can influence one another's evolution in unexpected ways. Meanwhile, red giants demonstrate the inevitable transformation that awaits many stars, a spectacular end stage that recycles matter back into the cosmic environment, helping to sustain the ongoing dance of creation. Together, these stars highlight the dynamic and interconnected nature of the galaxy. They remind us that stars are not static or isolated, but part of a vast, ever-changing system. The energy and matter they release through their life cycles shape the environment for future generations of stars and planets, and perhaps even for the emergence of life elsewhere in the Milky Way. In this way, by studying binary stars and red giants, we're not just observing distant suns, we're witnessing the fundamental processes that have made our own existence possible. Cradles of creation, star nurseries, and nebulae. One of the most breathtaking and awe-inspiring sights in the galaxy is the vast glowing clouds of gas and dust known as nebulae. These spectacular celestial formations serve as the cradles of creation, immense star nurseries where the story of birth and renewal unfolds on a cosmic scale. To gaze upon a nebula is to witness the galaxy breathing life into itself, a continuous cycle of creation that stretches back billions of years and will continue for billions more. Nebulae are not just pretty cosmic clouds, they are bustling laboratories of star formation. Within these dense regions of gas and dust, gravity quietly weaves its magic. Over time, pockets of material collapse under their own weight, growing hotter and denser until the very core ignites with nuclear fusion, the birth of a new star. This process can take millions of years, yet from our distant vantage point, it appears almost instantaneous, a dazzling flash of creation in the dark vastness of space. Some of the most famous nebulae, like the Orion Nebula and the Eagle Nebula, have become iconic symbols of this cosmic process. The Orion Nebula, visible to the naked eye from Earth's night skies, is a vibrant and dynamic region where young stars shine brilliantly, their intense radiation sculpting the surrounding gas into intricate shapes. Pillars. These luminous newborns energize the nebula, causing it to glow with spectacular colors, pinks, reds, blues that have fascinated astronomers and artists alike. The Eagle Nebula, famous for the pillars of creation captured in stunning detail by the Hubble Space Telescope, is another stellar nursery where dense columns of gas and dust shelter new stars in the making. These pillars act like cosmic incubators, protecting fledgling stars from harsh radiation while feeding them the material they need to grow. It's a powerful visual metaphor, towering spires of creation rising out of the void, a testament to the galaxy's ability to renew and regenerate itself. Beyond their beauty, nebulae hold the key to understanding our own origins. The Sun, Earth, and the entire solar system were born from such a cloud of gas and dust billions of years ago. By studying these star nurseries, scientists unravel the mysteries of how stars and planets form, how they evolve, and how the elements essential to life are forged in stellar furnaces and dispersed through space. In these cradles of creation, the cycle of cosmic life plays out in slow motion, with each new star lighting the way for the next. It's a reminder that the galaxy is not a static, lifeless expanse, but a living, evolving system. Every glimmer of light born in these nebulae is a spark of hope, a new beginning in the endless story of the universe. Watching these regions is like watching the future unfold, a future filled with new suns, new worlds, and perhaps new life. Supernova, death and rebirth in the galaxy. In the grand theater of the universe, few events are as powerful or poetic as a supernova. These colossal explosions mark the death of a massive star, but rather than a quiet fading into darkness, they go out with a titanic bang that sends shockwaves across the galaxy. It is in these final fiery moments that a star leaves its most lasting legacy by tearing itself apart. It helps give life to future stars, planets, and even us. In a strange cosmic irony, a supernova is both an ending and a beginning, the closing chapter of one story and the opening page of countless others. A supernova begins when a massive star, many times larger than our sun, reaches the end of its life. For millions of years, the star has balanced two opposing forces, the inward pull of gravity and the outward pressure created by nuclear fusion at its core. But eventually, the fuel runs out. Fusion stops, the outward pressure fades, and gravity wins. The core collapses in an instant, creating an explosion so powerful that it can outshine an entire galaxy for a few days. A single dying star becomes one of the brightest objects in the universe. The explosion hurls the star's outer layers into space at incredible speeds, spreading a cloud of debris that contains some of the most precious elements in the universe. Gold, silver, iron, uranium. These are not made in the quiet glow of regular stars, but in the intense heat and pressure of supernova. Everything heavier than iron, in fact, owes its existence to these violent stellar deaths. When you hold a piece of jewelry, or feel the blood pumping through your veins rich with iron, you are touching remnants of ancient supernova that exploded long before our sun was born. It's humbling to realize that the atoms making up your body were forged in the hearts of long-dead stars. But the role of supernova doesn't end with scattering elements. Their powerful shockwaves sweep through space, slamming into nearby gas clouds and compressing them. This compression can ignite the formation of new stars, triggering a chain reaction of cosmic birth. In this way, the death of one star breathes life into many more, a ripple effect that keeps the galaxy constantly evolving and replenishing itself. It's a beautiful kind of recycling, one where the end of a stellar life fuels the rise of new suns and new possibilities. Some supernova even leave behind fascinating remnants, neutron stars and black holes. A neutron star is a city-sized sphere packed with more mass than the sun, so dense that a teaspoon of its material would weigh billions of tons. Black holes are even more mysterious. Regions of space where gravity is so strong that not even light can escape. These remnants continue to shape their environments, pulling in gas, dust, and even light, becoming invisible architects of the galaxy's evolution. Astronomers have long been fascinated by supernova, not just for their beauty and power, but for what they teach us. By studying these explosions, scientists can trace the history of the elements, understand the fate of stars, and map the dynamics of galaxies. Supernova remnants are like fingerprints left behind by ancient cosmic events, each one telling a unique story of creation and destruction. Ultimately, supernova remind us that in the universe, nothing is truly lost. Even in death, stars contribute to the ongoing dance of cosmic creation. They illuminate the truth that endings are never really endings, just transformations. Somewhere in the night sky, a star may be exploding right now, unseen by our eyes, but seeding the cosmos with the building blocks of future worlds. One day, millions or even billions of years from now, a child on a distant planet may look up at the sky, unaware that the very ground beneath their feet was once part of a star that died long ago. The galactic core, into the heart of the Milky Way. As we journey deeper into the Milky Way, past the calm spiral arms and their peaceful clusters of stars, we begin to notice a dramatic shift in our surroundings. The space around us grows increasingly crowded, the stars closer together, their light more intense. We are approaching the very heart of our galaxy, the galactic core, a place so dense, so radiant, and so mysterious that it feels like stepping into the furnace of creation itself. The galactic core, or the galactic bulge, as it's often called, is a massive spherical region filled with hundreds of billions of stars. Unlike the relatively peaceful neighborhood of the Orion Arm, where our solar system resides, the core is a bustling metropolis of celestial bodies. Stars here are packed tightly together, sometimes separated by just a fraction of the distance between stars in our local region. The result is a brilliant, blinding landscape where the night sky would never be truly dark if you stood on a planet within it. Instead, you'd see a perpetual starry glow, a sea of suns stretching in every direction. But brightness is only part of the story. The galactic center is also a region of unimaginable energy and complexity. Powerful magnetic fields twist through the area like invisible wires, guiding high-energy particles at near-light speeds. Enormous clouds of gas and dust swirl chaotically, constantly bombarded by radiation from nearby stars and mysterious sources. It's a place of turbulence and transformation, where forces collide and merge in unpredictable ways. One of the most awe-inspiring features of the galactic core lies hidden at its very center, a supermassive black hole known as Sagittarius A*. With a mass over 4 million times that of our Sun, this gravitational monster sits silently, pulling in stars, gas, and dust that wander too close. Though black holes are invisible by their nature, the material swirling around Sagittarius A** forms a bright, hot accretion disk, lighting up the area with X-rays and radio waves. It's the ultimate paradox, a pitch-black void surrounded by a halo of light. This black hole doesn't just consume, it influences the motion of everything nearby, like a king on a cosmic chessboard, shaping the orbits of stars over tens of thousands of light years. Surrounding this black hole is a population of ancient stars, some among the oldest in the galaxy. These stellar elders carry with them stories of the Milky Way's earliest days. Their chemical fingerprints hint at the conditions that existed when our galaxy was young, chaotic, and still forming its iconic spiral shape. Observing these stars is like opening a time capsule. They reveal how the galaxy assembled itself, how early star clusters merged, and how the supermassive black hole might have grown to its current size. Studying the galactic core from Earth is no easy feat. The thick clouds of interstellar dust between us and the center block most visible light, making direct observation with How did Sagittarius A** grow so massive? Did it form from the collapse of a single giant star, or did it build up over billions of years by devouring other stars and gas clouds? Could it be the product of mergers between smaller black holes? And does it occasionally wake from its current quiet state to flare up in powerful outbursts, as some data hints? Understanding Sagittarius A** is not just about decoding the Milky Way. It's also about piecing together the broader story of galaxies throughout the universe. Nearly every large galaxy appears to have a supermassive black hole at its center, suggesting a deep connection between black holes and galactic evolution. In a way, black holes are like the hidden engines of the cosmos, silent, invisible, and yet essential to shaping the structure and fate of galaxies. In 2022, humanity took a historic step toward demystifying Sagittarius A** when the Event Horizon Telescope, a global network of synchronized radio observatories, produced the very first image of the black hole's shadow. It showed a glowing ring of gas surrounding a dark central void, offering a stunning visual confirmation of a phenomenon once thought to be purely theoretical. This image didn't just prove the black hole's existence, it marked a triumph of science and technology, a testament to our determination to see the unseen. Sagittarius A** remains a place we cannot yet visit, but its pull on our curiosity is as powerful as its grip on space-time. It reminds us that the most extreme and mysterious corners of the universe are not far-off wonders in distant galaxies. Some of them lie right here in our own backyard. At the center of our cosmic home sits a monster, not of myth, but of physics, waiting to reveal its secrets to those brave enough to seek them. Cosmic highways, navigating the spiral arms. Imagine standing on a starship, looking out at the Milky Way from above. Instead of a scattered field of stars, you'd see a grand, sweeping spiral of light and motion arms curling out from the center like celestial rivers. These spiral arms are not fixed structures, but dynamic, flowing regions where stars, gas, and dust are continuously in motion. They are the Milky Way's highways, directing the traffic of the galaxy and shaping its ever-evolving structure. The spiral arms are not solid features, nor are they simply composed of stars clumped together. Instead, they are density waves regions where the material of the galaxy becomes more concentrated as it orbits the center. Think of them as cosmic traffic jams, areas where stars and gas slow down temporarily before continuing their journey. As clouds of gas move into these denser regions, the increased pressure can trigger the birth of new stars. This is why the spiral arms shine so brightly. They are full of young, hot, massive stars that burn intensely and illuminate their surroundings. As we explore the Milky Way, we come to appreciate the spiral arms not just as beautiful structures seen in telescopic images, but as vital components of galactic life. They are regions of creation and destruction, of order and chaos, of movement and change. Navigating these cosmic highways, we are reminded that our galaxy is not static. It's alive with activity, constantly reshaping itself through forces both visible and hidden. In the grand journey across the stars, the spiral arms are our signposts and our paths. They guide us through the Milky Way, connecting us to the past, and pointing us toward the future as we continue to explore the galaxy we call home. Rogue planets and lonely wanderers. Imagine a planet adrift in the vastness of space, with no S traveling along one of these arms, such as the Perseus arm or the Sagittarius arm, is like riding a current through a living, breathing organism. You would pass glowing nebulae, where new stars are forming from collapsing clouds of hydrogen. You'd witness supernova remnants, the ashes of massive stars that exploded in brilliant death, scattering heavy elements into space. Star clusters would dot the landscape, some freshly born, others already beginning to drift apart. Gravitational forces from the galaxy's central bulge, nearby stars, and even dark matter all play roles in shaping these spiral arms. They twist and bend, influenced by tidal forces and the pull of massive structures. The movement is complex. Stars don't stay locked in place within the arms. Instead, they move in and out, like cars on a crowded highway flowing through a city. Despite this motion, the pattern of the spiral arms remains because new material keeps entering and being compressed, continuing the cycle of star birth. Our own solar system resides in a relatively quiet section between two major arms, in a region known as the Orion Spur. From this vantage point, the spiral arms stretch out like glowing corridors, hinting at the grand design of our galaxy. We are just one tiny speck among billions of stars navigating these lanes. But through observation and exploration, we can begin to trace the paths that stars have followed for billions of years. These spiral arms also act as galactic lifelines, distributing materials necessary for planet formation and life. The same heavy elements forged in ancient stars and scattered by supernova travel these cosmic roads, eventually finding their way into new solar systems. In a sense, the spiral arms are not only highways of stars and gas, they are delivery systems for the building blocks of life. Run to orbit, no warmth from a nearby star, and no solar system to call home. These are rogue planets, celestial nomads, silently drifting through the galaxy's darkness. Unlike the planets we know, which trace neat paths around stars, rogue planets travel alone, untethered and unlit. Their existence feels almost poetic, mysterious wanderers, lost to the shadows of the Milky Way. How do these planets become wanderers? Some are thought to have formed around stars like any other planet, but were later ejected from their systems by gravitational disturbances, perhaps after a close encounter with a massive planet or a passing star. Others may have formed directly from collapsing clouds of gas, similar to how stars form, but without accumulating enough mass to ignite nuclear fusion and shine. However they came to be, rogue planets represent a fascinating twist in our understanding of planetary formation. Because they don't reflect the light of nearby stars, rogue planets are incredibly difficult to detect. Astronomers often spot them through gravitational microlensing, a method where the rogue planet's gravity briefly magnifies the light of a distant background star. Sometimes, sensitive infrared telescopes can detect the faint heat these objects emit. But even then, their presence is elusive, like trying to find a black pebble in the middle of a moonless ocean. Despite their isolation, Rogue planets might not be entirely barren or lifeless. Deep within their interiors, geothermal heat from radioactive decay could keep subsurface oceans warm, much like the oceans believed to exist beneath the icy crusts of moons like Europa or Enceladus. If this is the case, then life, even in some primitive microbial form, might have a chance to emerge or persist in these hidden, insulated environments. These lonely wanderers challenge the notion that a planet needs to orbit a star to be interesting, habitable, or worth studying. In fact, rogue planets might be more common than stars themselves, making them a potentially vast and untapped domain in the search for extraterrestrial life. Their existence reminds us that the universe does not always follow the rules we expect, that chaos and isolation can be as natural as order and connection. Some scientists have even speculated about the possibility of entire rogue planetary systems, planets with their own moons, perhaps even ring systems, all drifting through space together without a central star. In such systems, tidal heating between the planet and its moons could generate enough energy to sustain liquid water and complex chemistry. These systems could resemble miniature, starless solar systems, entire worlds tucked away in the folds of darkness. Rogue planets also spark the imagination when it comes to interstellar travel. With no gravitational bonds to a parent star, they might be easier targets for future missions designed to explore planets beyond our solar system. They float freely, awaiting discovery, silent testimonies to the violence, variety, and vastness of our galaxy. As we continue to scan the skies and refine our methods of detection, we may find that the galaxy is full of these quiet drifters. Each rogue planet carries a story of formation, ejection, and survival in the loneliest corners of space. They are reminders that not all journeys follow a path, and that even in the emptiest regions of the cosmos, there is still mystery, wonder, and perhaps the spark of life. Globular clusters, ancient cities of stars. Far beyond the spiral arms of the Milky Way, orbiting in vast halos around our galaxy, lie some of the most awe-inspiring and mysterious structures in the cosmos. Globular clusters. These are not just clusters of stars. They are tightly packed, ancient stellar metropolises. Each globular cluster contains hundreds of thousands, sometimes millions of stars crammed into a space just a few dozen light-years across. Imagine the night sky on Earth, but with stars packed so closely together that darkness would barely exist. That's what it might look like standing on a planet within a globular cluster. These clusters are some of the oldest known objects in the universe. Many of their stars formed over 12 billion years ago, making them nearly as old as the universe itself. In a way, globular clusters are living fossils, glowing archives of the early cosmos. Their age and composition offer astronomers a window into the conditions that existed shortly after the Big Bang and during the formative years of the Milky Way. The stars in globular clusters are mostly ancient, low-metallicity stars, meaning they contain fewer elements heavier than hydrogen and helium. These chemical fingerprints indicate that these stars were born before many of the heavier elements were common in the universe, before generations of supernova enriched the cosmos with metals like carbon, oxygen, and iron. By studying globular clusters, scientists gain crucial insight into how galaxies like our own formed and evolved. One of the most fascinating aspects of globular clusters is how gravitationally bound they are. Despite their age, these clusters have remained intact for billions of years, held together by the collective pull of their stars. Their spherical shape is a natural outcome of this gravitational equilibrium. Yet life inside one would be anything but quiet. Gravitational interactions among the densely packed stars can cause chaotic movements and even lead to rare cosmic events, such as stellar collisions and the formation of exotic binary systems and millisecond pulsars. Because of their age and stability, globular clusters also raise tantalizing questions about the possibility of ancient civilizations. If life managed to arise early on one of the planets orbiting a star in one of these clusters, could that civilization have had billions of years to evolve? The extreme density of stars would also make interstellar travel between systems potentially much easier than in our region of the galaxy, sparking the imagination of those searching for signs of intelligent life. From a distance, globular clusters appear as radiant jewel-like spheres hovering in the darkness, quiet but powerful reminders of the universe's vast history. Some of the most famous, like M13 in Hercules or Omega Centauri in the southern sky, are visible even through small backyard telescopes, offering a direct glimpse into the deep past. Orbiting in the outer halo of the Milky Way, these clusters maintain their ancient paths like sentinels, circling the galaxy for eons. They are not part of the galactic disk, but are instead scattered across a spherical halo, forming a kind of gravitational scaffolding around the galaxy. Some may even be remnants of smaller galaxies that were devoured by the Milky Way long ago, their cores preserved as glowing particles and actions. But despite decades of experiments and deep space observations, dark matter has remained elusive, yet its fingerprints are everywhere. It guides the way galaxies form, merge, and evolve. Without dark matter's gravitational pull, it's unlikely that galaxies would have formed at all or stayed together. In simulations of the early universe, dark matter seeded the cosmic web, drawing ordinary matter into filaments and nodes that would become the first stars and galaxies. Even today, when astronomers map the universe on the largest scales, it's the dark matter structure that shapes the grand architecture of space. One of the most dramatic pieces of evidence for dark matter comes from observations of galaxy collisions, like the famous bullet cluster. When two galaxy clusters crash into each other, the visible matter, stars and gas, behaves differently than the unseen mass. Using gravitational lensing, scientists can map the location of the mass during such collisions, and they find that the majority of mass doesn't coincide with the hot X-ray emitting gas clouds. It's as if the invisible matter passed through the collision unaffected, while the normal matter lagged behind. Despite its ghostly nature, dark matter is not some abstract theory confined to the pages of scientific journals. It is a dominant force shaping our everyday reality, holding the galaxy together, governing the motion of stars, and influencing the future of the universe itself. Without it, our Milky Way would never have taken the spiral form we admire today. The Sun and Earth would never have settled into their stable orbits. Life as we know it may not even exist. In many ways, dark matter is the universe's greatest unsolved riddle, a reminder that even with all our technology and telescopes, most of the cosmos remains hidden from view. But the pursuit of understanding it continues to drive some of the most advanced scientific efforts on Earth and in space. Perhaps one day we'll uncover what this invisible skeleton is truly made of, and with it, unlock a new era of cosmic discovery. The halo and the edge, peering into the unknown. As we journey beyond the luminous spiral arms of the Milky Way, past the starry neighborhoods and brilliant nebulae, we arrive at a mysterious and seldom explored frontier, the galactic halo. It's not a solid boundary, nor a glowing ring, but a vast spherical region of space that envelops our galaxy like an invisible aura. Here, the bright density of stars thins out dramatically. The soft glow of familiar constellations fades into a dim sprinkling of ancient stars, rogue clusters, and dark matter. This is the edge of the Milky Way's realm, where our galactic home slowly dissolves into the deep silence of intergalactic space. The halo is elusive, almost ghost-like. Unlike the dense, bustling disk of the Milky Way, the halo is made up of sparse populations of stars, globular clusters, and a colossal cloud of dark matter that extends hundreds of thousands of light-years beyond the galaxy's core. Many of the stars found here are old, some of the oldest in the galaxy, remnants of a time long before the spiral arms had taken shape. They orbit the galactic center in wild, elliptical paths, often tilted in strange directions. It's as if they're following ancient trails, echoing a history written across billions of years. But the halo is more than just a quiet outer layer. It's a record of galactic cannibalism. The Milky Way, like many galaxies, has grown over time by swallowing smaller galaxies. When these cosmic interlopers ventured too close, their stars and matter were torn apart by tidal forces and scattered across the halo. Astronomers have identified several stellar streams, elongated ribbons of stars stretched across the sky, which are the remains of these galactic mergers. Each stream is a breadcrumb from the past, revealing the path of a now-vanished galaxy that became part of our own. Within the halo lie globular clusters, ancient spherical gatherings of hundreds of thousands of stars bound tightly by gravity. These stellar cities may have formed alongside the early Milky Way or come from the smaller galaxies we absorbed. Studying them gives us clues about the early conditions of the universe, like examining ancient ruins to understand the first human civilizations. Their chemical makeup and orbital behavior are like cosmic DNA, telling stories of birth, migration, and assimilation. Yet, the most dominant component of the halo is the dark matter, that same invisible material we explored earlier. While we can't see it, its gravitational fingerprint is clear. It helps anchor the halo's structure and extends the Milky Way's influence far beyond its visible edges. Without dark matter, the stars and clusters in the halo would drift away. Instead, they remain loosely tethered, orbiting silently in this enormous bubble of invisible gravity. The edge of the halo represents more than just the boundary of the Milky Way. It marks the transition from our galactic neighborhood to the vast intergalactic medium, a place filled with tenuous gas, radiation, and the gravitational pull of other galaxies. It's a frontier, both literal and symbolic. When spacecraft like Voyager 1 venture into interstellar space, they pass through regions influenced by this extended halo, exiting the domain of the sun but not yet leaving the galaxy entirely. Exploring the halo is one of astronomy's great challenges. Its contents are faint and dispersed, making them hard to detect. But as technology improves and surveys become more precise, we're uncovering more of its secrets. Projects like Gaia, which maps stellar positions and motions in exquisite detail, are helping to chart the complex web of stars and streams in the halo, allowing us to reconstruct the Milky Way's long and violent past. In the halo, time seems to stretch out. The stars are old, the motion is slow, and the distance to the next galaxy begins to shrink. This is where the story of the Milky Way fades into the backdrop of the cosmos, where our home becomes just another galaxy among billions. Yet, by peering into this quiet, shadowy realm, we don't just see where the Milky Way ends, we glimpse how it began. The Andromeda Approach, a collision in the making. Far beyond the spiral arms of our Milky Way, across the cosmic sea of stars and darkness, looms a silent giant, the Andromeda Galaxy. To the naked eye, on a clear night, it appears as a faint smudge in the sky, easily overlooked, yet unimaginably vast. Andromeda is the Milky Way's closest galactic neighbor of similar size and mass. But it is more than just a neighbor. It is a cosmic dance partner, slowly but inexorably heading our way. Andromeda is approaching us at around 110 kilometers per second. At first glance, that might seem fast, but in the vast scale of the universe, it's more of a steady drift than a headlong rush. The collision, or rather the merger, will not occur for another 4 billion years or so. Yet this future encounter is written into the structure of both galaxies, governed by the inescapable pull of gravity. The space between them is slowly shrinking, and though we live in a relatively calm corner of the cosmos now, our galactic future holds a spectacular upheaval. When we imagine a collision, we often think of chaos and destruction. But a galactic collision is not like a car crash. Galaxies are mostly empty space, vast expanses, with stars spaced so far apart that the likelihood of actual star-on-star collisions is incredibly low. Instead, the gravitational forces of each galaxy will begin to distort the other, stretching spiral arms, flinging stars into new orbits, and creating long tidal tails of gas and stellar matter. The first approach will look like a celestial ballet, as the Milky Way and Andromeda begin to twist and warp, their shapes pulled into elongated streamers. The supermassive black holes at each of their centers, Sagittarius A** and Andromeda's central giant, will spiral toward each other over time, eventually merging into an even more massive black hole, likely surrounded by a turbulent disk of gas glowing brightly in X-rays. Over millions of years, this slow-motion merger will continue, with both galaxies passing through each other multiple times. After perhaps a few billion years of gravitational wrestling, the galaxies will settle into a new form, a single massive elliptical galaxy. Astronomers have already given this future hybrid a name, Milkomeda, a poetic blend of the Milky Way and Andromeda. But what does this mean for us, the tiny inhabitants of a solar system tucked in the Orion Arm? Surprisingly, life on Earth, if it still exists, then may not be dramatically disrupted. The solar system could be flung into a new orbit or cast out into a more distant part of the newly formed galaxy. But the odds of the Sun or its planets directly colliding with another star remains slim. What's more likely is a profound change in the night sky. Over eons, stargazers, if any still exist, would witness Andromeda growing larger and brighter in the heavens, eventually filling much of the sky before merging into a swirl of new stars and gas. This future merger is more than a cosmic spectacle. It's also a powerful scientific laboratory. By studying Andromeda's motion and modeling the gravitational interactions between the two galaxies, astronomers gain insight into how galaxies grow, evolve, and interact. We've already observed many such mergers across the universe, from compact colliding dwarfs to dramatic twisted galaxies caught mid-Chalcyon in distant parts of the cosmos. Andromeda and the Milky Way give us the rare opportunity to study one up close, even if the event lies billions of years ahead. The Andromeda approach also reminds us that nothing in the universe stands still. Galaxies are not isolated islands. They drift, merge, and transform. Each collision is not an end, but a beginning of something new, a reshuffling of stars, gas, and gravity that leads to the birth of new stars, new structures, and new possibilities. So as Andromeda sails silently closer across the cosmic void, we're reminded that the universe is not frozen in time. It's alive with movement, transformation, and epic stories written in the stars. And One of the most dramatic chapters of the Milky Way's story is still to come. Reflections from the stars. What the Milky Way teaches us. As our journey across the Milky Way comes to a close, we are left not with silence, but with awe. A quiet reverence that stirs deep within. We've traveled through glowing nebulae, witnessed the fury of supernova, danced along spiral arms, and peered into the black heart of the galaxy itself. And now, as we look back from the edge of intergalactic space, we ask, what has the Milky Way taught us? The first and most humbling lesson is scale. The Milky Way stretches over 100,000 light-years across and contains an estimated 100 to 400 billion stars. Each of those stars may host its own collection of planets, some dead, some teeming with activity, and others perhaps not so different from our own Earth. In that vast sea of suns, our solar system is but a grain of dust suspended in a sunbeam. Yet within that grain lies the spark of consciousness, capable of asking questions as large as the galaxy itself. The second lesson is motion and change. The galaxy is not a static backdrop to the universe. It's a living, breathing entity. Stars are born in clouds of gas and dust, live brilliant lives, and die in bursts of light, giving their materials back to the cosmos. Planets form, black holes consume, and spiral arms twist like ribbons through time. Even the mighty Milky Way is on a path of transformation, destined to collide and merge with Andromeda in the far future. Everything changes, and yet, in this chaos, there is rhythm, a cosmic choreography driven by gravity, time, and energy. The third lesson is interconnection. Every atom in our bodies, the calcium in our bones, the iron in our blood was forged in the heart of a dying star. We are, quite literally, made of stardust. That poetic truth connects us to the galaxy in the most intimate way. The same forces that govern the orbits of stars also shape the molecules of life. In studying the stars, we are studying ourselves. Then there is the lesson of perspective. When we gaze at the night sky and trace the hazy band of the Milky Way, we're not looking outward, but inward into the very heart of our home galaxy. That perspective reminds us that we are not separate from the universe. We are a part of it, an expression of its unfolding story. From the smallest microbes on Earth to the grandest galactic phenomena, all are chapters in the same cosmic book. And perhaps the most powerful lesson of all is curiosity. The Milky Way beckons us not just with facts and figures, but with wonder. Every discovery leads to more questions. What lies at the edge of the halo? How did dark matter shape our galaxy? Could life be thriving on distant exoplanets? What came before the stars, and what comes after the galaxies fade? Our journey through the Milky Way is a mirror to the human spirit, a spirit that dares to ask, seek, and imagine. Though our physical voyage may be limited for now, the journey of the mind